In my right hand, I have a tennis ball. In my left hand, I have a bowling ball. Very different objects. If I were to drop them from this height to the ground, they would both accelerate at the same rate and hit the ground at the same time. Now, a very common misconception is that this happens because the gravitational force on both objects is the same. This is not true. There is much more force pulling this bowling ball down than there is the tennis ball. Acceleration isn't only determined by force, it's also determined by the mass of the object. So let's look at the force diagrams. I made up some masses. Let's say that tennis ball has a mass of 0.2 kilograms. When I drop this tennis ball, there's going to be a gravitational force pulling it down. And that gravitational force is equal to the mass times the strength of the Earth's gravitational field. Now, another common misconception is that I'm going to multiply the mass by 9.8 meters per second squared. That also is not true. I'm multiplying by 9.8 newtons per kilogram. This is because here on the surface of the Earth's gravitational pull is 9.8 newtons on every 1 kilogram of mass. All right, so when I do this, I get 1.96 newtons of gravitational force, aka weight. Now, when I first drop the objects, they're not moving fast enough to bump into a whole lot of air molecules. So at the beginning, the amount of air friction that would be resisting the downward motion is negligible. All right, now let's come over to the 9 kilogram bowling ball. To find this gravitational force, or the size of this gravitational force, I'm going to multiply 9 kilograms times 9.8 newtons per kilogram, and that's 88.2 newtons. So the amount of gravitational force on the bowling ball is 88.2 newtons. The amount of gravitational force on the tennis ball is 1.96 newtons. All right, this is about 45 times larger than this. It's not the same gravitational force. The reason they accelerate at the same rate is when we look at the net force divided by the mass. So to find the acceleration of the tennis ball, I'm going to take the net force in the y direction and divide by the mass of the tennis ball. This will give me the acceleration in the y direction. So the only force in the y direction is 1.96 newtons, and it's down, so I put a negative sign in front. I'm going to divide that by the mass of the tennis ball, and this comes out to be negative 9.8 meters per second squared. Now I'm going to do the same thing for the bowling ball. The mass is 9 kilograms. And I'm also going to get negative 9.8 meters per second squared. So when we do net force divided by mass for both objects, we get the same acceleration. Now, if you think about this, this net force is just mass times 9.8. So for any object, the net force is the mass times 9.8, and then divided by the mass. The masses cancel out. This is why, in the absence of air friction, all objects accelerate to the ground at negative 9.8 meters per second squared.